Hello YouTube, this is Umozo3. In the previous lesson, we basically brought up something called the exec function, and we said that basically exec of a particular string will basically interpret whatever's in the string as though it were actual official Python code. And we've also been bringing up this notion of an iterator, which is a type of object which is particularly good at iterating through the elements in a particular data structure. And then we've also talked about this notion that if all of your code is embedded in functions, then you can go ahead and run your module as though it were a script. So if you say if underscore underscore name underscore underscore equals double quotes underscore underscore main underscore underscore double quotes colon, basically any code that you execute within the context of that if statement will be executed as the first thing that gets printed on the console. And then it will be up to you to decide at your own discretion which of the functions and methods you want to call within your class. But the point is that this line of code would allow you to start your program at a particular place, and then it would go ahead and execute these lines of code. And we can think about what these would do, right? Because we were talking about in the previous video about exec, okay? And so what we can do, I think I still have a little bit of a comment about this, but basically if we say exec of x, so exec function accepts a string x that represents Python code, and so you can actually put Python instructions into a string. And then if you call exec of x, it just executes the Python code that's represented by the string x. Hopefully that's clear to you. But anyway, what we can do is we can run a little simple example here, and I want to show you what's going on here. So what we're going to do is try to think about this output. So we're going to say if name equals main, and then we're going to say exec of a equals, and then a tuple. So we have a tuple 52309. So it's going to go ahead and assign a, the variable a, to be a tuple with these 5 incident, with these 5 elements. And then we're going to say exec of b equals, and then it looks like a string potato times int of 2.3. So let's think about what this line of code does. These double quotes here are showing up in orange because we have to use an escape sequence if we want to print a string literal within the exec function, right? You can see exec already accepts a string. So the question is, how do you put a string inside of a string? Like, how do you assign b to potato, like the string potato, if you're already inside of a string? And the answer is to use an escape sequence, and we've talked about that in a previous video. So it would assign b to the string potato, and then if you multiply a string by a particular int, we said in the previous video that that has the effect of multiple concatenation. So you would basically get 2 repetitions of potato, and so that's why you would say b equals potato potato, right? And then if you say exec of c equals a comma b, so what does this do? Well, basically it creates a tuple called c, and it assigns it to the elements a and b. So here a is going to be a tuple with 5 elements in it, and b is going to be a string with 12 characters in it, because if you do potato potato, if you have 2 potatoes, that would be 12 characters. But anyway, the c is just going to be the tuple with the a and b in it. So if you say length of c, we get 2 because there are 2 elements in the tuple. And then what if we say exec of d equals length of c of 1? So here c of 1 should be 12. The length of c of 1 should be 12 because there are 12 characters in that string. That string, that's at index position 1 in the tuple. So if you say d equals length of c of 1, and then you say print d, then you go ahead and get the 12. And then what if we say exec of print of type of exec? And so what we could do is we would basically see that that's a built-in function or method, right? So it's calling exec, but then we say print of type of exec, and it tells us it's a function. So that's an example of using the type function as we've talked about recently, right? And then we also do a little bit of tuple unpacking. So here we do tuvw is equal to 4 functions, it looks like. So t is going to be equal to the exec function. It's like a function reference variable. And then u is equal to type, right? So if you call u of 2, that will give you type of 2. That would tell you that 2 is an int. And then v is going to be assigned to map, the map function, and then w is going to be assigned to the filter function. Remember, the map and filter generators, right? Map of function iterable and filter of predicate iterable. And then we can say count a equals 0 for x and v of u, s for s in apples are awesome. If s equals a, count a plus 1. So basically this would basically be talking about the map of function iterable, because that's v, it's a function reference variable. And then what function are we putting into map of function iterable? Well, that would be type. Okay, so for each of the types, I guess, applied to this iterable, so it's BS for S in this string, if that particular character is an A, right? So it looks like there would be 3, right? This would basically go ahead and give you this, I guess, would give you basically the string A, right? So you would have A as one of the elements, and then A for the next element, and then A for the third, because there are 3 A's, and apples are awesome, right? But you would say, you would basically go ahead and increment count A each of those times, right? So this is an example of passing a list comprehension into the map of function iterable generator, and then also using function reference variables, right? But you could say print number of A's using map of function iterable, right? And then you could basically say 3, because here we have an example of a string formatting technique where we called the variable coconut, but then we assign coconut to be whatever the value of the count A variable is. And then we could say print reset, so reconcatenated with set.lower. And then we could say t of count A equals 0. So what is t? So we said t is equal to the exec function. So it's sort of like a nested exec. It says exec of, and then you need double quotes again. So that's why you need an escape sequence, is because now you're going to have double quotes inside double quotes. That's what would happen if you tried using exec inside of an existing call to exec. It's like exec of exec. It's like a nested, but you need t of count A equals 0. So it basically has the effect of reassigning the value of that instance variable to 0. And then we could say t of print count A, and then we could say for y and w of lambda s, such that s equals A, okay, and the iterable apples are awesome, and then we could say count A equals count A plus 1. So this would be doing it, instead of with map of function iterable, we would be using the filter of predicate iterable, because in the function reference variables, we said w is assigned to the filter function, right? And then we have a predicate, whether or not the particular character is an A, and then the iterable, so that would be the string apples are awesome, right? But you would get the same count, so you would get 3 again, and again the number of A's, but with filter of predicate iterable will be 3, right? And then remember iterators, so we could say my set equals frozen set of, and then we pass in a list, and it looks like the list has a lot of 70s in it, and then we have a few 75s, and then a 72, and then a 67. Then we're going to say Delaware equals iter of my set. And then we're going to say for u in range of 744 to 744 plus length of my set, going up by 1 each time. So basically this would execute the number of times equal to length of my set, right? Because you're just going with 744 to 745 to 746 to 747. But the point is that would have that the code would iterate length of my set times, right? If you're just going to 744 up to 744 plus length of my set, what's the difference? It's length of my set. And you say exec of PA concatenated with SS.lower. So exec of pass, well, that function, that line has no effect. But then what if you say exec of print of next of Delaware? And so it would go ahead and give us the elements in that particular frozen set, and it would iterate through them. And so we would get a 72, a 67, a 75, and a 70, because of those are the unique elements that appeared in the list. And we said that frozen sets can only have unique elements, right? And then we could say try print of gonna try to print another next, right? So then what if we go ahead and iterate through the elements in the frozen set, and then we say print next of Delaware, and then we can say print did I make it here, right? But then accept a stop iteration. So what if we have a stop iteration error? Like what if we use an iterator to iterate through the elements in a data structure, but then we call next and there's no next element. So then if we can suspect that we're going to get a stop iteration, we could go ahead and catch it and handle it and say, oh wait, no more elements, right? So it runs as much of the try block as it can, but then it jumps down here and it says, oh wait, no more elements, right? And then it says finally runs regardless, because we know the finally block runs regardless. And then it says, and then we can do a last bit of review. And the last thing I want to review in this video is the min function. So remember with numeric functions, we were talking about how min and max, right? And so we could say min of a collection of arguments. So min of basically star x. So you would treat these arguments as though they were coming in as a tuple. But if you have min and then a bunch of arguments, so min of a, comma b, comma c, comma d, that would return min of t as though the arguments were coming in as a tuple, and that requires you to have at least 2 arguments. Okay, so they either need to both be strings, in which case you would get the minimum string lexicographically, like the first one that would appear in the dictionary, or you could do a minimum of ints or floats, obviously, right? But you could do print min of a tuple, and that will give you the minimum element in the tuple. You could do minimum of a list. You could do the minimum of a set. You could do the minimum of a string, and that will give you the character that would appear first in the dictionary, right? And then you could also do the minimum of a dictionary. So you could do min of, and then we have 2 key value pairs. So we assign the key 100 to the value 200, and then we assign the key 64 to the value 300. So the question is, what's the minimum of this dictionary? And then if we go ahead and take a look at that, it tells us 64, right? So I guess we got 1 here, and then we got 2 for this one, and then 0 for the list, and then 3 for the set, and then A for the string, because A is the least character lexicographically in dog dare, right? And then the minimum key would be 64. So min of D returns the minimum key. Okay, we can bring that up in the next video, but that's a point worth mentioning. And then what if you say print min of frozen set of 82045? So that would return the minimum in the frozen set, and that would be 0. So hopefully that's clear to you. What we're going to do in this video is talk about the arrays class. So I want to talk about matrices and basically techniques that you have available to you when you work with matrices. So what is a matrix? Well, we're already familiar with lists and tuples, and we know that lists and tuples can store ints and floats in them. They can have numeric data types. And it turns out that if you have a list or tuple of lists or tuples, where each of the individual elements is an int or float, we can characterize a numeric list of lists or list of tuple or tuple of lists or tuple of tuples as a matrix. And so what we're going to do is create a class called arrays, and we're going to come up with some static methods and define what they do. Because if you've ever studied linear algebra and you've studied mathematics, you know that we can add 2 matrices together. So we're talking about, for example, a matrix could have 2 lists in it, and each of the lists has 4 ints. So that would be like a rectangular matrix where you have a certain number of rows and a certain number of columns, and each of the rows has to have the same number of entries. Okay, that's what's called a rectangular matrix. You have to think about having like 8 lists or tuples in the same list or tuple, and then for each of those 8 lists or tuples, you're going to have 5 numbers or 12 numbers. But the point is that you'd want it to be a rectangular data structure where not only the number of rows, the number of lists or tuples in your matrix is constant, but also the number of elements in each of those lists or tuples is constant. But those are going to be numbers. So it's like a list or tuple of lists or tuples where each of the elements is a number. It's like a rectangular grid of numbers. Hopefully that's clear to you. That's what a matrix is. And that's what we talk about in linear algebra. So we're going to create a static method, and we need the static method decorator on line 4. And then we say define sum matrix of matrix 1 and matrix 2. And so this returns the sum of 2 matrices defined by list or tuple of lists or tuples, where each corresponding list or tuple must have the same length, and the ultimate elements are either numbers, or if you want to concatenate strings together, you can pass in strings. So you could basically pass in 2 matrices into the sum matrix function and return the sum of the 2 matrices. So we have matrix 1 and matrix 2 coming in. And we're going to say result equals and then an empty list. And we're going to say for k in range of length of matrix 1, new row equals the empty list. And then within that for loop, so we're going to have a nested loop, and then we're going to say for w in range of length of matrix 1 of 0, new row dot append of matrix 1 of kw plus matrix 2 of kw, result dot append of new row. And that will basically have the effect, one at a time, of appending rows onto your sum matrix. And then you're going to go ahead and return the sum matrix. But the point is that that should have the ability to add 2 matrices together. And so I just wanted to try a couple of different things here, so we can just try to consider a couple of these different matrices. So we want to try out the sum matrix functions, but the point is that if we try summing 2 matrices together, basically how that operation is defined is we just add the elements together at each of the corresponding positions, right? And so then what we could do is we could go ahead and say, let's try to print a sum matrix, right? And then we could do for each of the matrices. So why is that not printing? So let's go ahead and run it. So here we have an example of a program that will not finish compiling until the user specifies some input. So we have matrix A equals and then a list of lists. So it has two lists within this list. And one of the lists is 4, 2, and then int of input, and then 9. And then the second list is 6, 10, 11, 5. But the point is that this code is not going to finish executing until we specify a value for input. And we said that input returns a string by default, so that's why we have to cast it to an int, because presumably we're going to be adding these two matrices of numbers together, but we can't add a string to an int, so that's why we have to say int of input, but we need to feed it something, right? So let's give it 15. So hopefully you can see this, but down in green here, I'm typing in 15 for user input, right? And then it can basically go ahead and tell us the rest, right? So let's print the sum matrix. So 4 plus 3 is 7. 2 plus 0 is 2. 15 plus 7 is 22. So that's why this element, why this number shows up here, is because we specified 15 for the user input, and 15 plus 7 is 22. But the point is that it goes ahead and adds the corresponding entries together in the two matrices. So hopefully that's clear to you. And then we can also have a difference matrix. So this would just be the difference of the two matrices, and you do the exact same thing. Literally the only difference in the code is that instead of saying matrix 1 of KW plus matrix 2 of KW, you would say matrix 1 of KW minus matrix 2 of KW, but you go ahead and still, it's the same syntax, same letters, same variables, result append of new row, and then return result, right? And then what about the subtraction matrix? So then if we went ahead and tried to subtract these two matrices, well, what's 4 minus 3? It's 1. What's 2 minus 0? It's 2. What is 15 minus 8? What's 15 minus 7? It's 8. Okay, and the reason why we get an 8 here is because we passed in 15 as our input, right? As our user defined inputs. That's another example of that, but we could say, we could just print, the particular rows in arrays.sum matrix. So you say matrix A equals, and then matrix B equals. These are two matrices. But then you say for F in arrays.sum matrix of matrix A with matrix B, print of F. So hopefully that's clear to you. And then we could do the subtraction matrix. We just talked about that. For F in arrays.difference matrix of matrix A comma matrix B, print of F. And it's a static method, so that's why we call it directly on the class rather than an instance of the class. And it returns something, right? It returns a two-dimensional array. It returns basically a list, but each of the elements in the list are in fact lists. So that's why these are two lists being printed on the console. And then we could also have the minimum or maximum element in the particular list, right? So what if we say uses the min of x numeric function discussed previously, and so we could say min values equals an empty list. What if we wanted to find the minimum element in the rectangular matrix? So we could say for k in matrix, min values dot append of min of k. So that would basically go ahead and add the minimum element in each of the rows to this min values list. And then we would just want the minimum within those minimums, right? So you would just say return min of min values, and that would tell us that the minimum entry of the first matrix is 2, and then you could figure out how you could basically replace the word min with max to get the maximum element, right? But you could say minimum entry of the first matrix would be 2, right? The maximum element of the second matrix was 20, right? This 20 shows up here on line 171, so hopefully that's clear to you. And then the last one we could do is we could say the total number of numbers between the two matrices. We could say print of my string plus string of arrays dot number of entries of matrix A plus arrays dot number of entries of matrix B. So if we scroll up to the arrays class and then scroll down to the number of entries function, we can learn about what this does, but it returns length of matrix 1 times length of matrix 1 of 0. So it'll give you the total number of numbers that are being held in the matrix, because it would be the number of rows multiplied by the number of columns, and it would essentially give you the capacity of the rectangle how many elements can be held by it, right? So if we say total number of numbers between the two matrices, it's 16, because one of the matrices can hold 4 times 2, and then the other matrix can hold also 4 times 2, and 8 plus 8 is 16. So we'll review more of these methods for matrices in the next video, but hopefully that was interesting. From Mimosa3, thanks for watching, and please subscribe.